MeshCollider Optimizer helps generate cleaner, lighter, and more controllable colliders directly inside Unity. For skinned meshes, the tool can also work as an animated collider. In this setup, the collider updates with the animated pose at runtime. This is useful when collision needs to follow character motion instead of staying static. The update rate can be tuned for different performance needs. Every frame gives the most responsive result. EveryNFrames reduces update cost. TargetHz allows collider updates to run at a controlled frequency for more predictable runtime behavior. Increasing the refresh rate improves motion tracking. Lower values reduce runtime cost. This makes it easier to balance responsiveness and performance depending on the character and scene. This example returns to a convex workflow on a container-like mesh. The result is shown as a compound convex approximation. This is useful when a mesh needs physics interaction but still requires a readable overall shape. Rigid bodies are dropped into the container to validate the collider in motion. This helps check contact behavior, interior coverage, and general stability. It is a quick way to confirm that the collider is not only lighter but also practical during runtime interaction. As more rigid bodies accumulate, the collider continues to support the form consistently. This kind of test is useful for baskets, holders, and other open shapes where believable containment matters. The shirt example starts with a more high-fidelity, concave result. This keeps the collider closer to the visible mesh and preserves more of the original form. It is useful when shape accuracy matters more than aggressive simplification. Lowering quality produces a much lighter concave result. This reduces collider complexity significantly. It is a strong option when the render mesh contains more detail than the collision setup actually needs. Increasing shape fidelity keeps the collider closer to the visible silhouette. Inflate and deflate can push the result outward or inward to refine the fit. This is useful for recovering volume after simplification or reducing overly tight contact. A lower-cost concave pass shows how far simplification can go while still keeping the overall shape readable. This makes it easy to compare lighter and denser collider versions directly in the inspector. Returning to a higher quality result makes the trade-off clear. A tighter collider preserves more detail. A lighter collider gives stronger savings. The final choice depends on whether the asset needs precision, lower cost, or a balance between both. The workflow can also switch to preset-driven convex optimization. Lighter presets reduce complexity for performance-focused cases, while more balanced presets preserve more of the shape. This makes comparison faster across different production needs. MeshCollider Optimizer combines convex workflows, animated collider updates, practical validation, and fast optimization controls in one inspector-based pipeline. For more and to download, check the Asset Store page and documentation.